After I taught differential calculus on using a line to calculate a tangent, I'm going to introduce you to integral calculus, whereby we use shaded areas just to calculate what we have. So in this graph, I have an exponential pattern. It touches the y-axis here, and we can see that from this point axis to this point is a distance of a line, and this distance from here to here, it forms a rectangle, which is this line multiplied by this line. To increase this area, I can put a second triangle and calculate this area. But you can see, as soon as this parabola goes up, the line is no longer straight. Like you can see that if you put in a triangle or a square or a rectangle, it won't fit here. It's no longer a line, it's a curve. So in integral calculus, it gives us a tool to calculate areas which are no longer straight lines, which are curves. So this area under a curve will be on our spotlight as we do integration. Now I'm gonna go into some examples to see how integration works. The first one that we're gonna do is from last year's exam question. It was question 9. It's written, determine the following integrals. The integral of -4 dt. To solve this, 9.1 is an integral of -4 dt. According to integral formula, if we have a number, it turns out to be -4x. So that's our integral from this one. The next one, 9.1.2, the integral of x to the power 5 multiplied by x to the power 3 minus 9 x to the power -6 dx. So I'm going to calculate the integral of these terms. X to the power 5 multiplied by x to the power 3 is going to be x to the power 8 minus 9x -6 positive 5 -1, and it's still dx. So for the final step of this integral, is going to be x to the power of 9 over 9 minus, for this one, is going to be -1 positive 1, which is equal to 0. So x to the power of 0 is 1. So I'm gonna have 9 here. To show that I've integrated this problem, I'm no longer gonna introduce the dx. So this is the integral of this problem. This week, before we write the exams, I'll be solving integration, and on Wednesday I'll teach you guys optimization from differential calculus. How do we maximize or minimize production in an industry. And on Thursday and Friday, I'll teach you guys statistics for those who are doing pure maths. Then from